Hello and welcome to Forrester High School Maths Department's National 5 Math Support Material. My name is Mr. McDonald and I'll be taking you through your topic today. Today our learning intentions are to understand the basics of trigonometry and to be able to find missing angles in a right-angled triangle using sine, cos and tan. Our success criteria: I can use my knowledge of trigonometry to find missing sides and angles of triangles. So the last video concentrated on sides. Today we're concentrating on angles of a right-angled triangle. So let's briefly recap over what we learned the last time. We know that with a right-angled triangle and a given angle, like this 30 degrees down here, we can name the three sides of a right-angled triangle. The hypotenuse is the side that is always opposite the right angle. That's not changed from our knowledge of Pythagoras' theorem. The two things that are new is the opposite side from the given angle is called the opposite side, and the adjacent side to the given angle, or the side that is next to the given angle, is called the adjacent. Now that we know how to name sides, we can also find the three trig ratios that you're going to learn in this course. There's sine x, which is the opposite side divided by the hypotenuse side. There's cos x or cosine x, which is the adjacent side divided by the hypotenuse side. And there's tan x or tangent x, which is the opposite side divided by the adjacent side. SOHCAHTOA is the acronym that you need to remember that order of events. So sine is opposite over hypotenuse, reading down this list. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. If you need to, come up with a mnemonic to help you remember that, like some old horse caught another horse taking oats away, or some old hamster caught another hamster taking orangeade. It doesn't really matter what it is, as long as it sticks in your memory. Today what we're going to talk about to start with is inverse operators. Now you all know that plus and minus are opposite one another. If you plus a number onto another number and then take the same number away, you're going to get back to what you originally started with. Same if you multiply a number by something and then divide it by that same something, you're going to get the original number that you started with. Okay? Some that you might not be aware of, or that you maybe are a little bit more rusty on, is the squared sign has an opposite, which is the square root. And also, now that we've learned sine x, tan x, and cos x, we know that these have inverses as well. Okay, the opposite of sine x is inverse sine x, sine to the minus 1. The opposite of cos x is inverse cos x, and the opposite of tan x is inverse tan x. I haven't put the x's in there, but these are the opposite operations. Sine and inverse sine are opposites, cos and inverse cos are opposites, and tan and inverse tan are opposites. So if you want to undo a tan, then you use inverse tan. If you want to undo a sine, you use inverse sine. And cos and inverse cos, just the same way. The way you can get that on your calculator, I know not everybody has a Casio calculator like this, but it should give you a general idea of where to find these things. If you press the shift button to get the values that are in yellow on your calculator, and then press either sine for inverse sine, cos for inverse cos, or tan for inverse tan, that's how you would type that into your calculator. Okay, so just be very careful. If you've got a phone calculator, it's probably a second function button rather than a shift button. If you're working with something other than a Casio, it's usually located in that top left corner, and then the second function of your sine, cos, and tan buttons. Okay. Right, so how do these things work? Let's start off by doing exactly what we did last time, writing down SOHCAHTOA. S-O-H, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Let's label the sides that we have information for. So we have information for the hypotenuse side, and we've got information for the adjacent side. From this given angle here, we don't know what its size is, but we know that that's the angle that we're looking for, so we have to think about our sides being named with relation to this angle. If we have the adjacent and the hypotenuse side and nothing for opposite, opposite is blank, so we're not going to be using opposite. we are using the cosine rule. We're using cos. So cos x equals adjacent side divided by hypotenuse side. We're going to then sub in the information that we know, just like we did before when we were looking for our side lengths. Cos x is equal to 15 over 18. And this is where we're going to use that inverse cos function. To get rid of that cos that is acting upon our x, our angle, we need to do cos to the minus 1 on both sides here. Inverse cos, inverse cos. All right, and in blue we've got the x is equal to the inverse cos of 15 divided by 18. Putting that in your calculator, you get 33.56 degrees. If you're not getting that answer, if you're working on a calculator, just check that one of the three letters that you could have at the top of the screen are D, R, and G. D stands for degrees, R stands for radians, G stands for gradient. We want our calculator to be displaying the letter D at the top of the display. We don't want R and we don't want G. Okay, so if you have got anything but the letter D at the top of your display, make sure that's changed to D for degrees, because we want our answers to be in degrees. Let's have a look at one more example. Again, quickly, we're going to name the sides. That x has an adjacent side there and an opposite side there. We don't have any information for the hypotenuse, so we're not going to be using that in our calculation. Write down our SOHCAHTOA. At this point, if you are comfortable not writing down SOHCAHTOA and knowing which function you're going to be using anyway, then that's absolutely fine. You don't need to write it down at the start of every question, but for me, I think it's easier to show you why I'm choosing the tan function if I've got it written down. Okay, so opposite and adjacent is the tan function I'm going to be using. Tan x is equal to opposite divided by adjacent. Tan x is equal to our 25 over 11. To get rid of tan, what I need to do is I need to do the inverse of tan. So tan to the minus 1 on both sides. Again, you don't need to write the bit down in red that I'm writing, but it just lets everybody know my thought process. X is equal to tan to the minus 1, inverse tan of 25 divided by 11. Again, if you're not able to put a fraction into your calculator like that, you can use just 25 divided by 11 in brackets. That'll give you the same answer. And the answer you should get for this one is 66.25 degrees. Okay, so make sure that you have one of those questions down in your notes, just so you got an example of how to find an angle using trigonometry. And then what I'd like you to do for today's lesson is, firstly, complete the activity on finding angles using trigonometry. It's 10 to 15 questions of just what I was doing there. That shouldn't take you too long at all. There's not a huge amount of thought. It's just applying the process. Secondly, I'd like you to try and challenge yourself with some exam samples of trigonometry questions. These are Nat 4 exam style questions. Some of them are finding missing sides, some of them are finding missing angles. Okay, you have to use what you have in the diagrams to decide which different methods you're going to use. And then finally, review your progress so far through the Nat 5 relationships topic with the exam prep exercises that I've put on there as well. That's about, I think it's 7 to 10 questions, all from past papers or all based on past papers to do with relationships. So you've got topics like quadratics in there, you've got topics like straight line, you've got topics like simultaneous equations, as well as these topics on trigonometry as well. Okay, thanks very much, folks, and I will see you next week. I'm looking forward to seeing your faces so much because self-isolation is not very fun at all. See you soon. Bye.